All right, hello everybody. Thank you to the organizers for giving me this opportunity to speak. My name is Sam Palmer and I'll be talking about thymic involution and disease risk rising with age, including COVID-19. This is work done in collaboration with Claire Blackburn, Thea Newman, Luke Alberganti, Rory Donnelly, and Nick Cunniff. Okay, so my story starts in the 1950s when Armitage and Dahl looked at cancer risk in various tissue types and found that if you look at a log-log plot, you find remarkably straight lines indicating power law behavior. Usually the slope is about 5, so risk rises like h to the power of 5. So you can interpret this as a waiting time for 6 rare events. So if you think of them as driver mutations, this is the idea that older people are getting more cancer because they are accumulating these driver mutations. So that seems pretty solid, but I'm actually going to challenge that in this talk. So a few years ago, Tomasetti and Vogelstein found a correlation between cancer risk in a given organ and the total number of stem cell divisions in that organ. The R-squared for this graph is actually 0.66, and they made headlines by saying that this implied that 2/3 of cancer was bad luck. So that's kind of beside the point. Here, I'm just going to be talking about this correlation. And what I realized is that this leads to a contradiction where what this is actually pointing to is more like one driver mutation. And if this is one driver mutation, that would imply constant risk with age. Okay, so what's going on? So I looked back at cancer risk rising with age and found, sure enough, many of them rise like power laws, but also many of them rise exponentially. So if you look at a log linear plot now, a straight line corresponds to an exponential, and a power law would correspond to a curve. Okay, so there are certain cancers which rise exponentially, and with a certain particular slope as well. So rising by about 4.5% per year, which is the same as doubling every 16 years. So then I realized that the thymus involutes at the same rate. So the thymus volume, or as well treks, decrease exponentially with a half-life of about 16 years. Okay, so I looked at other diseases now. These are plots ordered from best fit to worst. These are the CDC's ABC bacterial diseases and some viral diseases, bacterial with the yellow background, viral with the green background. And immune model 1 is just this idea that risk rises exponentially, doubling every 16 years. And that's in orange there, fitting pretty well for about half the diseases. And we also made this mathematical model, which involved T cells and antigens cross-inhibiting each other, which would lead to sort of switch-like behavior or some sort of threshold behavior. And as a model assumption, we assumed that this immune escape threshold would be proportional to thymic output. And that gives you immune model 1 straight away. And if you have biased stochastic fluctuations in this model, you get a slightly more flexible model, which is immune model 2. Okay, so that's in dark red there. Okay, and if you look at cancers now again, you find that immune model 2, since it contains immune model 1, just a bit more flexible, that can explain these exponential curves. And surprisingly, it could also explain the power law type curves. So immune model 2 and the power law model both just have 2 fitting parameters. So it's straightforward to compare them, and comparing them, immune model 2 actually fits slightly better over all cancers. Okay, and if you look at the gender bias in both cancer and infectious disease and also thymic involution, you find roughly the same. So a factor of 1.3 to 1.5. And in more supportive evidence, if you look at T lymphoblastic leukemia, you see approximately constant risk for adults. And so maybe what's going on is that risk is rising exponentially, just like the other diseases, but also decreasing exponentially because T cell production is decreasing exponentially. And possibly these exactly cancel, leading to constant risk in adults. Okay, and what we also found is that COVID-19 follows the same trend. So looking at data from various different countries, you see risk rising exponentially, doubling every 16 years. And also the gender bias is just what you'd expect, roughly a factor of 1.3, 1.4. Okay, great. That's it. Thank you very much. And looking forward to your questions. Thank you.